Yeah, you were saying something. 2x minus y is equal to 3. So what are we going to do to this? You will find if I ask you what is the solution of this, what will you say? Does it make sense? So it can have, I should not put the question saying what is the solution, rather I should call it as what are the solutions. So 2x minus y is equal to, sorry? Okay, 2x plus y is equal to 3. Okay, whatever it is. If you ask you what is the solution, what will you say? You need not solve it, you cannot tell the answer for that. What is the answer? It has infinite solutions. Why is it so? Because you can plug in multiple values into it, right? Which will give you the same 3. Right? For example, I'll put a half here and a 1 here. Right? What is one of the solutions? Half, comma 1. This is one way of representing. You write x is equal to 1, sorry, x is equal to half, y is equal to 1. This is another way of representing. Or I can write y is equal to 3 minus 2x. This is another way of representing. Right? If you see everything, we are doing the same thing but in a different way. Accepted? Right? Half and 1 varada. 1 and 1 varma. Yeah, 1 and 1, right? Okay, whatever it is. But I'm just trying to concentrate on this part. So x is equal to 1, y is equal to 1. Right? If you see, the different ways of representing is directing towards the same point. What are you actually doing? You're trying to find the solution of this equation. So when you find the solution, you're indirectly finding the value of x and y. Right? So can I call this equation which is actually representing the relation between these two terms? What are the two terms? X and y. Right? So if I break down the x and y and write it in this form, in which branch of mathematics does it fall? Okay, you can say set also, which you call it as? What is this kind of representation called as in set? Cartesian point is in terms of coordinate geometry, but he is saying set, no? I want to stick to set. You call it as an ordered pair. You have heard this term, right? So ordered pair in set is the same thing as coordinates in coordinate geometry. Right? So means what am I trying to tell? This 1, 1 has a significance. What is the meaning of it? If I take a graph sheet, right? If I take a graph sheet and draw this 2x plus y is equal to 3, what does it represent according to mathematics? A linear equation in two variables, what does it represent? It's some straight line. I don't know how it is going to look like. I drew a straight line. On this straight line, one of the points will be 1, 1. Makes sense? Right? So we are talking about the same thing in different languages. Right? Different branches of mathematics, rather, I would put it like that. Right? So this is ordered pair, or you can also call it as Cartesian point. Okay, accepted. This x is equal to y 1 and y is equal to 1. What do you call this as? You can call this as one of the solutions of this particular equation. It's not an expression, right? It's a, what is the difference between both? 2x plus y is an expression, is equal to equation, right? As simple as that. So y is equal to 3 minus 2x. What is it? It is an equation. And where do you write this as? Instead of y, one scary thing that always comes is f of x is equal to 3 minus 2x. Right? In your 9th grade also you learned this. In the name of p of x is equal to 3 minus 2x. There it was easy finding zeros, plugging in the value. 11th standard, same functions, you got stuck. Right? It's the same meaning. So what I'm trying to tell here is, if you bottle down to what actually relations and functions are, basically, as the name suggests, relation is going to be, what is it? Can you give me a statement? A relation basically what? It is a mathematical way of representing how two terms are related, in which one of the terms you call it as independent terms and the second you call it as dependent terms. You know what is independent and dependent, right? What is the meaning of it? For example, if I have this 1, 1, this is x coordinate, this is y coordinate, which one is dependent on the other? Suppose I write a point like this, 1, 2. Which one is the coordinate of a dependent variable? Which one is the coordinate of a independent variable? 2 is dependent on y, 1 is independent. So to put it very simple, it depends on how you are writing the expression. If you write y is equal to 3 minus 2x, y is dependent, x is independent. Can I write the same thing in a different way? X is equal to? Now which is dependent, which is independent? So it's all the perspective. So which one you're trying to call it as dependent and independent, but if nothing is mentioned to us, by default, y is always dependent, x is always independent, right? In terms of coordinate geometry, you call it as, what do you call it as? X-axis has another name, something that starts with A, abscissa and ordinate, right? So basically, if you write something in this form, abscissa is going to be the independent variable and ordinate is going to be the dependent variable, as simple as that. So if you look at the bottles, if you bottle down to the main point of why we actually study relations and functions, it is mainly to frame frame equations and understand how those functions perform not only in mathematics, also in other branches of science. For example, everybody is a science student, right? No commerce student sitting. The commerce, okay. But this you would have seen in your 10th grade. V is equal to U plus 80. Right? Can I call this also as a relation? Right? So when I use the word relation, the first thing that I need to identify is I need to choose which one is dependent and which one is independent. In the meaning expression, V is equal to U plus 80. Final velocity is changing as a function of
initial velocity
and actual time. Final velocity is changing with time. U and A actually is a constant, but okay. The same thing what you will do is, if I write y is equal to 2 plus 3x, observe, v is replaced with y, t is replaced with x, other two are just numbers. So you're able to understand. So relations and functions is the basic thing for you to understand a bigger branch of mathematics, which is calculus. Last year you would have learned limits and derivatives. Why did we study that? Why do we need that chapter in the first place? Limits and derivatives, what are we doing? Hari Raghav, can you tell me what did you learn from that chapter? In limits, you would have broken down the equation into smaller parts and you would have checked. You would have, every question would have had this term as check whether the limit exists or not. What is the meaning of it? You would have found something called as left limit, right limit, function value. If the equal, you call it as limit exists. If not, it does not exist. At least something you remember. Even if you don't remember, don't worry. I'm just trying to connect the dots. You have heard of something like this, right? Right? Why are we doing it? Did you ever put a question of why? You learned it. But if you know the same chapter in your 12th grade is given a different name called as continuity and differentiability. That is the 5th chapter. Are you able to understand? So they both are connected. So the very first point that we need to understand is we need to bottle down to the concept of what are relations and functions. Okay. So for which I need to go and touch the first chapter of your 11th standard. Only then I can bring the connect. Okay. I'll try to explain it with a simple block diagram in one line of what is actually relations and functions. See if you're able to understand. Okay. If there is any question, I want you to ask me. Okay. You would have drawn something like this, no? 1, 2, 3, let's say x, y, z. Right? You would have drawn something like this. What are these? Basically, this is one set. This is one set. Yeah, this is another set. Okay, you call it as domain, codomain, or whatever it is, that we'll see later. Basically, bottling down, it is a set, this is another set. So what do sets contain? They contain a collection of data. So this is a collection of what you are able to see. I wrote 3 simple numbers. They are collection of first 3 natural numbers, and this is a collection of 3 letters from the English alphabet. That is X, Y, Z. So can I frame a relation between them? Can I frame a relation between them? If I frame a relation, right, my question is only one thing. If I have to write the set in the roster form, how do I write it? Charger. In the phone use. How do I write it? 1, 2, 3. How do I write this? Okay, I write something like this: x, y, z. Sorry. Right? Okay. If I do some operation like this, you would have seen this. Don't say you didn't see. What is it? How do you read it? You read it as A cross B, right? But what is this operation mathematically called as? It is the Cartesian. It is a Cartesian product of two sets. So Cartesian product means literally you are not multiplying the numbers. You don't write it as 1x, 2x, 3x. What do? You write 1, x, 1, y, 1, z. Right? So if I do A cross B, what am I going to get? 1, x. Sorry. Okay, I'll go in the order. No, 1, x, 1, y, 1z, 2x, 2y, 2z, right? 3x, 3y, 3z. So when I do the Cartesian product, how many elements am I getting? Here I have 3 elements, here I have 3 elements. So I'm getting 9 elements, 3 into 3. Right? I'm getting 9 elements. The collection of this set, what are these called as? This 1, x, what are they called as? They are called as the ordered pairs. Ordered pairs, right? So, if I call the set A as collection of individual elements, I repeat the question, listen to this carefully. Set A is a collection of individual elements, then what do I call the set A cross B as? It is a collection of ordered pairs. Can I say this A cross B itself as a relation? A cross B a relation? Check your textbook. Those who have your textbook, can you read the statement of what is a relation? But unfortunately, they would have started with types of relation, but you need to know. See if you are able to recollect something. Hariharan, any guess? What is a relation? Aditya? It could have been a relation also, we don't know. But I cannot completely call this whole thing as a relation. So how do you define relation? That is a function. You are actually confused between both. That's a function. Okay, see, tell me one thing. Be on, okay, don't be in a blank thing. If you don't know, please let me know and I'll explain it. You're not able to recollect or something like that, please let me know. You're not able to?
It's about how two sets are related.
Okay, that can be how two sets are related. Now, can you tell me what are you talking?
So if suppose one set has like it should be like if suppose A cross B, then one is 1 and x. No, sorry, if we want to multiply, we are just multiplying.
Here it is not actually multiplication.
Not yes.
Relation is not multiplication. So I'll tell you. Basically, relation is a subset of the Cartesian product. Are you able to recollect what I'm trying to say? If I take some elements from the ordered pair, right? That ordered pair, if I write it as a separate set, then that can be called as a relation. Okay? So R is a subset of Cartesian product, A cross B. Right? Under relation, you have something called as function. But as of now, I will stop with relation because our topic is first understanding what is relation and what are the different types of relation. My objective is very simple. I want you to solve the problems on your own. Okay, for that, you need to understand the theory behind it. Now, I hope this point clear? Could you understand? So what is the basic thing with which we are actually starting? What is that we are provided with? We are provided with two sets, and for those two sets, what is the operation you are doing? Cartesian product. So Cartesian product is giving you a set of ordered pairs, and some ordered pairs from the Cartesian product or all the ordered pairs from the Cartesian product could form a relation. So if I have to consolidate and give you a simple data, can I say it like this? Set 1, set 2, right? Set 1 comma set 2 are given to you. What do? You do Cartesian product, and what does it give you? Set of ordered pairs, and from this set of ordered pairs, what do you take out? You take a subset, then that gives you a relation. So to put it simple, these are the 4 steps. That is all I need. So if somebody asks you to frame a relation, what is the first thing you need to ask me? What are the 2 sets you are trying to talk about? Right? Once you give me those 2 sets, first thing I'll do is, I'll write the Cartesian product. I'll write the Cartesian product with all the elements present in the set. Then what will I do? Then I will get a set of ordered pairs. From those set of ordered pairs, you tell me which ordered pairs I need to select for you to have that relation. Right? That will form the relation. Again, the subset of relation is what is function. That I'll go next. Okay. As of now, this block diagram alone, make a note. Am I clear till this point? Right?